Quantum mechanics requires a measurement apparatus that operates entirely independent of the Schrödinger equation. General relativity dictates the exact geometry of spacetime, yet provides no description of the system that perceives it. Both frameworks require an observer that exists outside their own mathematical axioms. A theory of everything is structurally incomplete if it derives the forces, derives the matter and the gravity, but leaves the observer external to the system. We cannot close this gap by importing philosophical concepts like decoherence or consciousness to explain measurement. The Simplicial Consciousness Theory, or SCT, addresses this by grounding the observer in a single discrete structure, the D4 root lattice. This theory does not suggest that all matter is conscious. It also operates without relying on unproven physical mechanisms like objective quantum state reduction. The central claim is precise. The conscious observer is mathematically derived directly from the D4 lattice vacuum. Consciousness emerges as a strict, localized dynamical regime. It is a specific spectral filter operating exactly at the edge of chaos. To solve the hard problem of consciousness, we must identify the exact geometric architecture that constructs the observer from the inside of the physics. The foundational geometric unit of the D4 root lattice is the 24-cell boundary complex. Its structure is defined by exactly 96 edges. To understand how information propagates, we apply the Hodge decomposition to these 96 edges to separate their modes of vibration. The 96 dimensions split definitively. 23 become exact modes, topologically frozen, unable to palpitate. This leaves exactly 73 active coactive modes. Within those 73 active modes, we must separate the frequencies that allow for stable wave propagation from those that cause chaotic dispersion. Modes governed by irrational eigenvalues cause waves to scatter and lose structure. Dispersing energy, they are computationally silent. We filter this noise and isolate perfect square eigenvalues, an eigenvalue of 4 with a multiplicity of 12, and an eigenvalue of 9 with multiplicity 1. This yields the O13 projection operator. It is a specific mathematical filter that restricts all lattice dynamics exclusively to these 13 non-dispersive modes. This restriction is a theorem, not a hypothesis. Pure mathematics dictates that this 13-dimensional subspace exists within the lattice. If a system were exposed to the full 73-dimensional space, its internal state would dissolve into chaotic interference. The mathematically derived 13-dimensional subspace, designated V13, is the absolute prerequisite for any entity to process complex information without dispersion. It is the geometric definition of a stable mind. Defining the space reveals a new problem. The 24-cell boundary has the topology of a three-sphere, which impacts structural stability. According to the Lefschetz fixed-point theorem, this specific topology does not naturally guarantee a fixed point for the dynamics to rest on. To create an entity that can observe its environment, the system must enforce a unique equilibrium dynamically, achieving a fixed-point observer through restricted gradient descent. This graph shows the SCT evolution equation. It plots system behavior locked inside the V13 subspace. There are three thermodynamic regimes. In the first, the topological stall, the energy pump is too weak. Modes freeze in place, and the system collapses into an unconscious state. To avoid stalling, the system relies on Froelich condensation. This requires a specific non-equilibrium energy flux to overcome the thermal damping of the environment. There is a precise, calculable critical energetic threshold, EC, required to achieve and maintain this condensation. Pumped exactly at the EC threshold, it enters the second regime, the edge of chaos. The trajectory balances perfectly, creating a stable fixed-point observer. If energy pushes past EC, the system enters topological exhaustion. Excessive energy overdrives nonlinear coupling, breaking containment entirely. In biology, this chaotic dispersion of the coexact modes manifests physically as a seizure. Consciousness is a highly specific, actively pumped thermodynamic balancing act, strictly confined to the exact middle regime. We can map this mathematical filter and its energetic requirements directly onto the structure of the mammalian brain, specifically onto the primary cytoskeletal polymer in neurons, the microtubule. The microtubule reveals a central structural isomorphism. To function, it forms a cylinder made of exactly 13 protofilaments. This 13 protofilament geometry provides the physical architecture necessary to support the 13 independent channels of the O13 eigenspace. By organizing into 13 columns, the microtubule instantiates the mathematical filter within a biological substrate. To maintain the fixed-point observer state, this biological hardware requires an energy pump. It draws this from the mitochondrial electric field. This chart compares the required threshold with the measured biological output. The mitochondrial field provides 3.6 times 10 to the 7th volts per meter, which comfortably clears the mathematically required EC limit. Operating at this edge of chaos regime, the biological observer receives boundary input from its environment through the 5 concentric shells of the microtubule bundle. The outer 3 shells, the synaptic membrane, the actin mesh, and the map coat, act as the initial environmental coupling and impedance matching layers. Information then moves to the inner shells. The tryptophan lattice within the tubulin wall acts as an optical bus, utilizing superradiance to route data into the water-filled lumen, which functions as a quantum electrodynamic cavity for processing information. This layered, concentric architecture heavily attenuates chaotic noise. It ensures the internal O13 dynamics can process sensory perturbations without losing stability. The brain's physical architecture is the exact biological engineering solution required to instantiate the D4 lattice's 13-dimensional mathematical filter in a warm, noisy thermal environment. This raises a final experiential paradox. If the universe is built on a discrete, quantized D4 lattice, why does a biological observer perceive it as smooth, continuous 4-dimensional spacetime? The math of the O13 filter produces 2 perceptual phenomena. The first is the smoothness illusion. Because the O13 filter exclusively passes perfect square eigenvalues, waves propagate without dispersion. Without phase distortion, the underlying lattice spacing remains hidden from the observer. The second phenomenon is the boundlessness illusion. The Hodge decomposition governing the lattice is scale invariant. Because the mathematical relationships hold regardless of size, the observer cannot perceive the structural limits or boundaries of the vacuum. The Simplicial Consciousness Theory introduces 0 free parameters beyond standard lattice physics, yet it strictly predicts the 9:4 acoustic frequency ratio of neural processing and the explicit biological necessity of the 13 protofilament microtubule. Consciousness and physical mass are simply different dynamical regimes of the exact same underlying lattice. The observer is a geometric invariant of the D4 vacuum, instantiated wherever the 13-dimensional dynamics achieves equilibrium through sufficient boundary coupling. Reality contains the observer within its own geometric derivation.